Hi shed hackers, so in this video we'll be making a light sensing circuit or a dark sensing circuit. Now the components we'll need is a variable resistor, looks like one of these, an LDR which looks like that from above, a fixed resistor, and in this case it is yellow, red, violet, gold, a LED,
which stands for
light emitting diode,
okay,
and then a transistor, and another fixed resistor which is gold, red, black and brown. And the last thing is we're going to need a circuit, and this is actually bought offline.
Yeah, and it's called a printed circuit board,
or PCB for short.
Yeah, and you can see there the tracks of copper hidden under that green insulator, and you can see the little soldering points on the end of each wire connection, printed connection, and it's made from glass reinforced plastic. The actual board itself, you can see, very strong actually. Okay, here are the circuit symbols and the actual spellings of the words. With the transistor and the base collector and emitter, that's a NPN type. There's lots of different types of transistor, MOSFET and field effect, but for this you don't need to know. The fixed resistor, which was this one. There's the transistor, that's what it looks like there. Then we had the light emitting diode, okay, which is that one there. Jake, just get that there. The longer leg on the light emitting diode is positive, which is the anode, and the cathode is negative, but that's the circuit symbol there. It doesn't have these little positive negative symbols, but that's light emitting diode. And then we have the variable resistor, which is the same as the fixed resistor but with a line through it showing it can be varied. Then we have the light dependent resistor, which is that one there, you remember. And then we have a switch. We haven't put a switch on ours, but we could do later, but the switch is, the symbol is there. And then we have the battery supply. In this case it connects to the battery snap there, and the amount of cells is indicated by the amount of symbols within the two lines there. So that hopefully starts us off. Okay, thank you.
So this is the example that we're going to be making of the circuit. And first off, we're going to start with the LED. Now, if you look at it like that very closely, you can't see it on camera, but it has one flat side, and that side is negative. So this is going to go there and
you sure?
There.
Look at the... Is that right?
Yeah, look.
Yeah, it is, yeah.
Up.
Although the other symbol next to it is the diode symbol, but on this circuit that's where it goes. It's a bit confusing, isn't it?
So we're just going to bend the legs over with all the components to stop it from coming out.
So the flat side is the negative, and that's facing away from the positive.
And then we're going to get the transistor, which looks like this. And what way does it go around?
Follow the example there. So there's the example. Flat side's facing the base, the B.
So just going to...
The middle one in there, that's the base.
This can be a little fiddly if you've never done it before.
Sorry about the delay, guys. Shed hackers, I'm sure you're very patient.
You can just skip the video a couple of seconds if you get bored.
Goes in there, good. Push it in. Push it in nearly right down, but give yourself a little bit of freedom to move the legs around a bit. Okay, bend them over on the other side.
Like that.
Good. And next, Jake?
And then next we're going to get the fixed resistor.
Which one?
which is one of these.
Yeah.
And this is a gold, red, black, brown.
Brown, black, red is 1000 ohms, and ohms is the unit for resistance. So
Where does that go on the circuit?
that goes same place as the other one, next to the preset there. Can you see? Can you see? That's it. Yeah.
So we're just going
Put that in there. Push that pretty well all through.
to, with
No,
the resistor, you might as well just push it all the way through.
Now, interestingly, guys, with the resistors, these type, they can go round any way round. There's no polarity. Polarity indicating whether it has a positive or negative side to it. But yeah.
Then we're going to get the next
Same.
resistor.
Yeah, that goes the other colour. And that is yellow, violet, brown, and that is 470 ohms. So yellow's 4, 7's violet, and brown indicates the number of zeros. Okay, so 1, 0.
And what you can do is you can pull it through this side, like that, and then fold it over.
Brilliant. Okay, anything else?
And then we're going to get the variable resistor. And just like our example, we're going to put it in these two holes here.
Okay. We'll come back to Shed Hackers in a minute when we've put it all together and start soldering. Okay, just drilled that hole. We'll show you in a minute why we've done that, Shed Hackers. Okay, Shed Hackers, we've drilled a hole. Can you see there? We put the wires in from the other side and then poke them back into where they should go. And the reason is, if Jake pulls on the wire now, the battery snap, yeah, it won't break off eventually the actual battery snap from the circuit board, which often happens because you have a weighty battery on the end of here. And then when that pulls, it tends to break off from the board itself. Turn it around then, Jake. Okay, obviously we haven't soldered it yet, and then we're going to trim the legs, okay? So we'll solder now, and we'll do that on video. Okay, we've got all the components in there. Off you go, Jake. You're going to clean that soldering iron, did you say?
Yeah, you can just use a little bit of glass paper and just scrape it along like that.
A bit of wire wool.
Yeah, and be careful if it's on. So first we're going to solder this component here. Make sure you get heat on, then you solder, and put the solder on.
Right, and then off, quick. Now, why must it be done very quickly, Jake?
So you don't melt the circuit board and you don't damage the component by getting it too hot.
Okay, let's do one more then.
Let's do
Any one.
that one there.
Heat on, quick.
So heat on.
And... Right.
And make sure you don't breathe in the fumes because they can be dangerous.
Well, you can get lead-free solder, so it should be okay. But some of the fluxes they use that helps clean the soldering joint while you solder can be, you're right, can be a bit toxic. So you can get little fans that should take that out, or make sure you're in a ventilated space. So he's going to quickly solder all these on, and then we'll come back to you guys. Okay, Jake's just finishing off. There it is, he's just doing that last one there. In the bright condition, the LDR has a low resistance, and so the transistor is switched off. The LED is therefore off. In the dark condition, the LDR has a high resistance, and so the transistor is switched on. The LED therefore lights up, and it's the principle of a potential divider. So a little bit of research for you if you're really keen on this sort of thing. That's the basics of the circuit.
Now we're just trimming the legs of all the components. Make sure your pliers are nice and sharp and they're made for cutting wires, because some of them are just made for like moving things that are quite difficult or quite small.
So it's a general purpose light sensing circuit, and it uses the mini LDR to detect changes in the light level, and you can adjust the sensitivity by adjusting the potentiometer or the variable resistor. Just turn it over and show them the variable resistor again, Jake. Point to it. There, that's variable. Okay, and I'll just go, if you turn over again, that's how it should look. Are all the components look good? All the soldering? No. Where's that one I thought was a bit dry? If you see a joint that looks a little dry,
Almost white.
that's got a hole in it that I'm not sure about. That might need a little bit more heat on it. Can you see that white one again? Okay. That one, no, I think they're pretty good. But if they look blobby, or they've got little holes in them like that one, definitely just put some more solder on it. But if they're not shiny, and they're not evenly soldered onto the pad, that's the pad, you'll have a bad joint. And you don't want to solder across two pads, because that means you'll have a short circuit, so the electricity or the voltage jumps across in effect, and shortens the circuit, and that would mean that the circuit wouldn't work at all. That looks a bit not quite shiny, so we're just going to tidy it up a little bit, and we're certainly going to do that one there, and then we'll come back to you. Thanks, Shed Hackers.
So we just connected up the leads to the circuit board, and we're going to turn it on. Hey, it works! And this works by, if you put something over the LDR,
Yeah.
it will turn off. This is a really sensitive circuit, so it could almost be used with like a solar panel or something, so when a cloud comes over, it could like turn the power off or something like that.
Oh yeah, look.
And we noticed a little error. So this comes with a 50k or 50,000 ohms variable resistor, but we think it should come with maybe a 60,000
or even a 1 meg, 1 million. Alright, you can see 50k on it there, look.
And that's how you make a simple circuit like that.
Well
and
done. That's
not
excellent,
solder.
Jake. Excellent. Well done, Jake.
Just to finish off, this is the circuit, and that's the PCB, known as printed circuit board, and these are all the components. It is a light sensing circuit, but you can alter it and make it a dark sensing circuit.
Okay, I think that's great. Nice little project for the youngsters. Okay. Goodbye. Hi, Shed Hackers. Just a briefie about the colours on the resistor. I'll put the magnifying glass there. Can you see that resistor? You see the colours? There, I think you can. Well, the colours indicate the value. I've done a little bit of research with my son, and they're the values. Quite useful to know, so you know what ohmage the resistor is, having deciphered the colours, if you like, from it. So knowing the colours, you can understand which band represented here is which value then. Okay, so bit of research for you, and maybe you'll learn a little bit more about electronics that way. Thank you.